started. Alright, so this is going to be a lesson on the periodic table. So I'm just going to go over some trends with you on the periodic table, groups, how stuff is named, why it's reactive and why it's not. So if you got a periodic table, you can look on with me, or you can take notes on it, just like I'm showing you here. Alright, so we're going to start with this first column. Okay, I'm actually going to number the columns. So this is group 1, group 2, then we've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So there's 18 columns on the periodic table. You're going to hear me call them groups. So if they go up and down, they're called groups or families. They have similar characteristics, just like, how you see similar traits in family members, or you can say that they all have the same eyes or something like that. So just think groups or families are these columns, and they have similar characteristics. So they're going to act the same way. The ones that go left to right are called periods. They do not have similar characteristics. And you're going to see why in a minute, because it's going to go over it's going to go through a bunch of different sections of the periodic table as you're going left to right. The ones up and down have similar characteristics. Okay, so some of the groups have names, and we're going to go over them, and we're going to go over why they're reactive and why they're not. So the first group, these are called the alkali metals. Okay, so I'm just going to go ahead and color that group in so we can just kind of have a visual of it. Alright, so these are your alkali metals. That's everything in group 1. Second group, these are called your alkaline metals. That will be everything in the second column. So all the elements in the second column are going to have similar characteristics, just like all the ones in the first column have similar characteristics. Okay. Alright, back to group 1, the alkali metals. These are the most reactive metals. And that is because they have one outer electron. Outer electrons are called valence electrons. And you're going to see me do an E negative. That's a symbol for electron. So if you see that little E negative, it's just like shorthand for electron. Okay. So your valence electrons are the outer electrons. Those are the ones that's coming in contact with everything. I'm sure you've seen the little diagrams of atoms, and it shows the little rings around the nucleus. Right, you've got the electrons on little rings. So the outer ones are the ones that are coming in contact with everything, the ones that are bumping into everything and bonding with everything. So they're really, really important. The valence electrons, your outer electrons, go with the columns that they're in. Okay, so this first column has one, and I'm just going to put a V dot E negative, say it has one valence electron. Okay, the second column has two valence electrons. We're going to skip these in the center. This center section, these are kind of strange elements. These are called the transition elements. Sometimes they're called metals. Either one's fine. So they have a bunch of different strange properties, so we don't go into a lot with those. Just know that they're there, and it's group 3 through 12. Okay, so you do not have a trend with valence electrons with these elements. We're going to skip over those, and you're going to find out that we skip over those a lot in 8th grade science. You will also in physical science. You start to learn a lot about these elements when you get into chemistry. That'll be in high school. So for right now, we're just saying groups 3 through 12 are the transition elements, transition metals, and they don't have a valence electron trend. So they don't have a number that goes with their groups. Okay, so we said that the first group had 1 valence electron. Second group has 2. We're going to skip over these. Now we're to group 13. 13 has 3 valence electrons. 14 has 4 valence electrons. 15 has 5 valence electrons. 16 has 6 valence electrons. 17 has 7 valence electrons. And 18 has 8 valence electrons. Okay. So let's move over to this side. I just told you that this last group has 8 valence electrons. So 8 is the magic number to be stable. Okay, so everything wants to get to the number 8 to be stable for valence electrons. Since this row is already at 8, it's stable. So if it's stable, it does not bond. So none of the elements in group 18 bond. So you're not going to see it in a compound with anything. They're always going to be by themselves. So it'll just be neon or argon or krypton or xenon. So these elements in this are called the noble gases. And I always think of it like they're noble, like nobility, like they think they're better than everybody, so they don't bond with all these people down here. So they've already reached their stability, so they don't need to bond with anything. So those are noble gases. So I'm going to go ahead and color that column in. You're going to notice that I leave out a lot of these down here at the end. These are man-made. So I don't usually color those in with the ones I'm talking about, but I guess technically they would fit in with that column. So those are noble gases. The next group that we're going to look at is group 17. So they have 7 valence electrons. These are called your halogens. And your halogens are the most reactive nonmetals. Now I told you that the alkali, the ones in group 1, are the most reactive metals. This group over here. Those are your most reactive metals. Now we're looking at the most reactive nonmetals. That's going to be this group right here. So those are your halogens, group 17, and they have 7 valence electrons. So what that means, they are super, super close to being stable. All right, so they're almost to 8. So they're really, really violent, trying to get stable. So usually they're trying to take this 1 valence electron that's easy to lose. Since it's easy to lose, that makes it really reactive because it can be taken away easier. It's easier to take away 1 electron than it would be to take away 2 electrons or 3 electrons. So these are always losing them. These are always taking them. Okay? So I told you that these are the most reactive metals and the most reactive nonmetals. So how do we know where metals and nonmetals start? So that's going to be something, and most periodic tables have this in on it. You'll see a little stair step that starts under boron, and then you just go stair step it down until you reach astatine. So I've got a little stair step in. So the stair step is going to be called metalloids. And they have properties of metals and nonmetals. They also divide metals and nonmetals. So everything to the left of the stair step is going to be a metal, and everything to the right is going to be a non-metal. Okay. Aluminum is not a metalloid. We know that it's a metal. It has all the properties of a metal. Metalloids have properties of metals and nonmetals, so it might be shiny, but it might be brittle. But aluminum does not fit into that. So what we're going to do is we're going to go down through here and we're going to color in the metalloids. And you're going to notice when I get this colored in, you see most periodic tables have stuff colored in like this. So it's not, so when you look at it, you're just kind of looking at trends and you can visualize it better. Okay. So along the stair steps, those elements that are touching it, except for aluminum and acetone, we're not going to include that one either. But all of those are metalloids. So those are dividing your metals from your nonmetals. I'm going to go ahead and do right here is just kind of group these together. And we're just going to say these are nonmetals over here. They don't really have a name to their group. Sometimes you'll hear them referred to as like an oxygen group. But that's just going to be including these three right here, if you're talking about the oxygen group, because you can't go all the way down the group because you would be going into nonmetals, metalloids, and then a metal. Okay. Okay. Then we've got this group over here. These are just going to be your metals. They don't have a specific name because they're not really in a column that has a trend, because the column is going through a bunch of different stuff. And remember, we're grouping aluminum in with that too. Even though it touched the stair step, it's still a metal. Okay, so we have alkali metals, alkaline. We have the transition metals or elements. We have the noble gases, and we have the halogens. Okay, then we have your metalloids, and those are going to divide the metals from the nonmetals. Then we've got this little group right here of nonmetals, and we've got this little group right here of metals. They don't have a trend because the columns have different things in them. So it has metalloids and metals, or it has nonmetals, metalloids, and metals. So you can't give the whole column a name and a trend. In this section right here, we don't really go in a lot with it, with 8th grade science, but it does fit up into this area. We just bring it down here because if not, it would spread the periodic table out too much and you wouldn't be able to get it on a piece of paper. But these fit up in here. These are called the lanthanide and actinides. And that's pretty much it. So you've got your most reactive metals, most reactive nonmetals, the most stable. 8 is the magic number. And that's all because of valence electrons. And the columns tell you the valence electrons. 1, 2, skip these, 3, 4, 5, 6, 7, 8 for valence electrons. All right, hope that helps. Thanks. See ya.